guys want to do introductions? My name is Fred Trotter. I'm the founder of the DocGraph journal, and I create new open data sets about the healthcare system.
I'm Rob Sachs from Systems Very Simple.
Okay. We've met before?
We may
Maybe.
have different copies.
Systems Very Simple sounds familiar.
Richard Calaba from SAP.
Okay.
Rajiv Kamli, software consultant.
Cool. So, all right. So the basics of DocGraph is it is a A/B referral data set. So the way it works is if you give it a given year, and the 2012 data set just came out, or part of 2012 just came out. Let's say it's 2011 is the one that we've done the most analysis on. So 2011 data set. If provider A sees a patient on, say, January 15th, if provider B, and here's a 30-day window, right? Let's do time. 30-day window. If provider B sees the patient anytime in this window, provider B, then that means in our data set we have A, B plus 1, right? So it's a simple count of how many times it's occurred. So if provider B sees a patient and then provider A sees it, then we have a graph that looks like this, right? So that gets a plus 1. So the DocGraph data set in general is the number of times that that's occurred in Medicare between doctors and patients over the course of a single year in a given window. So we have different windows. We've got a 30-day window, 60-day window, 90-day window, so forth and so on. So you can actually get a 365-day window, but then you start having to go back into 2010 and into 2012 to get that full year window. But then you're basically talking about if two providers have seen a patient in the same year more than 11 times. 11 is the threshold for patient privacy, so anything less than 11 patients involved in their transaction becomes redacted, and we don't have that in our data set. But that's actually a good thing because it removes most of the noise in the data set. So let's say you see a cardiologist, you're over 65, you're under Medicare, you go see a cardiologist one day, and then you say, no, I'm not going to work with that cardiologist tomorrow, I don't really like him, I'm going to go to a different cardiologist. Well, that might happen 3 or 4 times between any given two given cardiologists. We remove that as noise as a side effect of having this threshold. So it ends up being a good thing for the purposes of data integrity and for getting a clearer picture, and also for just convenience of working with the data, since we'd have a lot more data if we didn't have that threshold. So with that in mind, we have, how many people here are familiar or comfortable with graph theory and concepts in graph theory? If I said that it is a directed weighted graph, does that sound familiar to you? So A to B is not the same thing as B to A, and then these have weights. So you can have 150 here and 75 here. So it's directed in the sense that AB is not the same thing as BA, and it's weighted because you have these two connections. So the this is the first version of the data was based on patient count, which means, let's say you had, 1,150 counts going this way and 175 counts going this way. I didn't know how many patients were involved in that encounter. So you could have one patient going every single month to provider A, then provider B, then provider A, then provider B. And that would be plus 10. It would be 10 of those. So I wouldn't know, in the first version of the data set, I wouldn't know if that 1150 equals, 11 patients about 100 times each, or if it's 10 patients one time and one patient 1,000 times. Right? I had no way of knowing that in the first version of the data. And we've just gotten a data update, again, which you can get to from DocGraph.org, where we have 3 columns now. So it's how many people know what I mean when I say an NPI? Heard that term before? NPI is a kind of an identifier in the healthcare system. Every individual physician is required to have one to bill Medicare. Most hospitals have one. Most hospital locations have one, sometimes two. You can have sub-organization NPIs, so it's just the core identifier of the healthcare system. So this has a number, it's the NPI. This has a number too. It's got an NPI. There's a data set called the NPES. I can't remember how to spell it. I think that's it. Maybe PPES, maybe this. Yeah, I think it's this one. NPES is the node database, and it includes the phone number, so it connects to phone, address, taxonomy, which is to say cardiologist versus rheumatologist versus internal medicine. So there's a taxonomy here. There's IDs. And they attach to the nodes. So this is our node database for our graph analysis. So there are 4.2 million nodes total. About half of those, so it's approximately 2 million, are active in the graph, which makes sense because people get an NPI and then retire. I have an NPI address as a computer expert. Obviously, I don't know Medicare under that NPI, so half of the NPIs are not necessarily used. 2 million active. In the first 30-day window of the data set, we have 48 million edges, and I think that goes up to 120 million edges if I remember correctly. So great. That's how the original teaming data graph looks. In a second here, let me pull out kind of what is a typical looking kind of demo of this. We get some nice graphs. Just a report, prescribing pattern report. All right. So you can imagine the kind of things you see in this data set look like this. First of all, the NPI also ties to a name. I guess that's important. So you have Dr. John Smith here, public information. So some other stuff in there, like a poorly categorized credentialing file, things like this. But that's a good thing to start with. So here is, let's say my doctor is Dr. Magid. And he has a couple of cardiologists, C1, C2, C3. And he goes lab providers. And I'll actually show you this in a second. And he's got a rheumatologist, and he's got a pain specialist, and so forth and so on. Does that make sense? Hi, how's it going? Come on in. Yeah, don't worry about the cameras. They're decoration. So anyways, you have this pattern. Now, a standard cardiologist, he might have, 20 providers for a primary care specialist. But a cardiologist will have, 50 primary care they're working with in total, or let's say 25 primary care, and then they're working with, hospitals and everything else. So that usually the specialists have more people they work with, which makes sense. So that's how the referral and the collaboration data sets. It is not strictly a referral data set. We call it that because it's the easiest thing to say. What it is, in fact, is a shared patient and time teaming and collaboration data set. Obviously, referrals are one way to do that, but wouldn't necessarily say that you send a referral to a lab to a patient. You just send out their lab work and they bill and you bill, and so they're connected. Right? So it's not necessarily actually referrals, it's more collaboration. But does anybody have any questions about how this data set works? Because this is the kind of foundational DocGraph data set. All right, sounds good. So this is my doctor here. Get rid of my brother who's pestering me online. And I'll pull up the presentation mode on this. But you guys can see, that's a typical graph. Now what we do is, on this particular display, what we've done is said that if you have a purple line, thickness of the lines is the degree to which you refer to them. Obviously, the thickest line here is this purple one. That's his actual practice right there. And if you have a blue line, it means you don't share a phone number or an address. And if you do share a phone number or address, then we can put that there. So you can actually connect as a graph there as well as address and phone numbers, which is useful sometimes. So, so this is kind of how the first level works. And then when you start looking at the same physician, but looking at his group, this is a way to look at the cardiologists in his group. So what I'm going to do is I'm going to pull this over. Obviously, I'm using D3, which has an excellent force-directed graph display library. But actually, I'm going to zoom in a little bit because that's unreasonably. Okay, not that much. All right. So you can see here, all of these blue doctors are all of the internal medicine specialists who share the same address or phone number as Dr. Maggin. So it's all of his practice members. And then all of the orange dots are the cardiologists. And you can see there's 3 cardiologists. We make the size of the node represent the degree to which the entire graph refers, and the thickness of the lines between them also are indication of strength of relationship. These are by far the most highly preferenced physicians, cardiologists in the group. All of these are secondary. And when we can change the center of gravity for nodes we haven't anchored, let's see here. By doing that, what we get is some immediate data about who is kind of referring to all this stuff. First of all, you see this guy is really not playing on the same team at all. He's referring to all of these different providers. This guy too. They're kind of on their own map. And then in fact, there's really only a few cardiologists and a cluster right here that anybody's worked with. Hi.
Hey.
Join us. I'm Frank.
Thanks, Brian. Nice to meet you.
Nice to meet you. So we're talking about kind of in general referral patterns. Mm-hmm. This is a diagram of primary care physicians and how they refer over to their cardiologists. Okay. Pulled from the data set. The first data set, again, as I was explaining, is referral data. It's based on a time window. So if you're a physician, he's a physician, I'm your patient. If I see you on January 15th, as long as I see him on or before February 15th, that counts as a 1 tick between you. Mm-hmm. And then we have that score. So it's a directed, weighted graph, right? Okay. If A is seen first in time before B, that's A, B, and then there's a 150 count, and then B, A might have another count of 75 or something like that. So it's a weighted directed graph. So does anybody have any questions about just the referral graph? Again, when I say referral, what I mean is shared patient and time graph.
What's the motivation for it to see who gets the most referrals, or is it like a proxy for quality? Or?
Well, it could be. So there are some procedures and some types of information, lots of surgical procedures where volume is equivalent to is an improvement to quality. Mostly, though, it's just a map. It just shows what's happening, who's working with whom, mm-hmm. What hospitals work with what doctors, and these kind of things. Hi. So, and just to catch you up, we have a weighted directed graph based on seeing the same patients in the same time. So if I'm a patient and these 2 guys are doctors, if I see him on or before January 15th, or on January 15th, as long as I see him on or before February 15th in a 30-day sliding window, that counts as 1 between them. So it's not actually a referral data set. It's really shared patients at the same time period data set. And then of course we have different windows. So if we have a 30, for 2011, I believe the 30-day window gave us something to the tune of 48 million edges between about 2 million nodes, and then 120 million if we went to a 365-day window. So obviously, if you have more time for the patient to go to the second provider, then you get a full graph. So this is the first part of the graph. It looks like we've probably got our entire talk in here, so that's good. This is the referral data. So you see things like, and again, I was just walking in. This is a D3 of the primary care providers who work with my doctor and all of their cardiologists. You see there's 3 that are kind of preferred by, and they actually work in the same building, makes sense. And then there's a couple that they kind of work with, and there's a couple that don't get any work at all, that are just kind of out here and randomly seen. So those are the kind of patterns we're used to seeing. So you might have a primary care with, lab providers and cardiologists, and then hospitals obviously are on here. So that's interesting stuff. So just to take a step back, what I do is although I guess I am a data scientist, it's not really what I spend my time doing. What I spend my time doing is figuring out how to get these data sets out of the federal government. So I make FOIA requests and I wrestle with them and argue with them and threaten to sue them, and then I do that on a national database, and I do it for state databases too. So I'm really a person who just goes and creates these big data sets in one way or another. And then there's a community of people on the DocGraph mailing list who actually spend their time analyzing them and looking at them. So there's guys like Ryan Weld, who's done some really amazing stuff, and some other people who've done a bunch of analysis on this. So most of what I'm telling you has been told to me by my kind of open data community. We're kind of the first. I think there's one other company that's trying to start as an open source data company as opposed to an open source software company, but that's kind of what we do for a living. So I got these data sets out of the federal government. Now,
what kind of data sets did you get out of the federal government? Like what?
All of them, I tried to get relevant to healthcare, usually relevant to the healthcare system, like other kind of maps. So, to your point, the other organization that does really amazing things is ProPublica. I don't know if you guys have heard of ProPublica. They're one of the organizations that's taking the lead on the Snowden analysis of the Snowden leaks. But they've got a couple of really top-tier data journalists over there, Charlie Ornstein among others, who they get data sets too. The data set that they got, which it takes a lot of arm wrangling to get data out of the federal government because they have some. They feel some responsibility to protect some aspects of provider privacy. Patient privacy is, of course, a foregone conclusion, whether they always protect that, but they also feel like they should protect the doctor sometimes. And so we get into debates about how much the doctor should be protected versus not. So the other data set that was really interesting that they got out was the ProPublica data set, which we have remarketed as DocGraph RX, which is about prescribing patterns. Do you want to ask a question?
Yeah, so what was the name of the organization? Where can we get access?
This is me.
Okay.
And then this is ProPublica. When you look for ProPublica, look at their data store, and they've got some downloads of their prescribing data. We usually have their data up for download too, but there's a lot going on this week in data. There's going to be a huge drop of data coming, which I'll talk about later. But so anything except that for us is lower priority. But anyways, you can download that from ProPublica, and then you can get the DocGraph referral data from docgraph.org. Okay, so the prescribing pattern data. The prescribing pattern data is really interesting because it uses the same technique. Well, just to give a little bit of history about what I do. In sometime around 1980, there was a lawsuit that the American Medical Association won against the predecessor to CMS, who's the people who administer Medicare and Medicaid, indicating that it was illegal for them to release any information that released providers' salary. So that was a specifically protected piece of information. My FOIA request got around that by you can't calculate salary from the edges. ProPublica did the same thing for their prescribing data set. That case has been overturned, and now there's going to be a bunch more data sets coming out, the first of which CMS just announced literally yesterday is going to be coming out 7 days from now, and it's going to be procedure data sets. So there's going to be a tremendous haul of data. So let me just explain how the prescribing data set works, and then the procedure data set will probably work in a similar fashion. So here's a given doctor. He's Dr. A. He's got an MPI, and MPI is a 10-digit identifier that uses a Loon number or Goon number. It's the same things how credit cards, you can check their validity just by looking at the digits and doing some math on them. I guess same kind of thing. So it's a very good, solid identifier. Just number is 10 digits. So you get provider A, and he's linked to, they've got two data sets, one which he's linked to drug names from the first data bank drug database, so that you have something like Lipitor, and it's literally strings like that. And then there's another database where that same provider is going to be linked to an NDC9 code. Does anybody here, I mean, I don't know does anybody here worked with healthcare informatics before?
Yeah.
You have, have you heard of NDC or drug codes or
Yeah,
these kind of
sure.
things? So normally they have 11 digits, you've worked with this. Normally they have 11 digits. This is a very messy numbering system, which has been poorly executed over the years. And NDC 9 is a not 100% consistent shortening of NDC 11 to collapse around code. So what's theoretically supposed to happen, there's lots of variants on this, but what it's supposed to end up as the first 9 digits of the ID. The first 9 digits are supposed to be basically the actual drug itself, and the last 3 digits, or 2 digits, 2 digits. Last 2 digits are supposed to be form, so tablet versus pill versus syrup versus this, but all the same stuff, right? And the manufacturer was given control over this 2-digit code. So when you registered for getting your new drug made, you would get these 9 digits, and then you would have some options to make those things yourself. But unfortunately, what some drug companies did is they used that to delineate the manufacturing process. So they'd say, there's this drug code, and then in here they would vary the numbers by format. So all the same first 9 digits were all of their syrups. One digit on the 2 is a stimulant, and the next is a depressant, and that's how they delineated this, which means there's about a 3% estimated inaccuracy mapping between NDC 9 and NDC 11 in terms of actual substances, which is, not great. So if you would like to use the NDC 9 version of the drug NPI to drug matching data set, you're going to have to use RxNorm. Anybody heard of that? Anybody? Okay, so RxNorm is this database that comes out of, I think the FDA releases it, that tells you what a drug is, what the various forms are. It's a semantic web database. It's extraordinarily complicated, but in it, every single packaging of any medication, tablets, this many tablets, 20 tablets, 30 tablets, it's in a packet, it's in a bottle, it's in this and all that kind of stuff. Ingredients, so a lot of medications are, this plus that. All of those kind of variations are all incorporated into RxNorm, which is a very, very extensive and intended to be semantically valid database. It's fairly hard to use, but you can get it in MySQL and play around with it. Okay, so this is kind of hard to use but valid. This is really easy to use, but there's a lot of, it's a very lossy, they prescribe Lipitor. Well, okay, what does that mean? That could mean you're getting a lot of Lipitor, a little Lipitor. There's a lot less you can work with here. So there hasn't actually been that much work here. It's interesting stuff, and nobody's taking a really careful look at it, probably because it's just so easy and fun to use. Because if you're using this, you can do all kinds of fun path analysis, right? So let's say you went to a hospital and you found out that this hospital was the best hospital for heart conditions in your town. You were new to a town, you went to a hospital. And you decided that you wanted to have the most generous prescription of Viagra you could possibly get in this market, but you really wanted to go to the hospital that was the good hospital for heart conditions, that you had a heart condition. And those might be related. So what you do is you say, well, here is all the primary care specialists, and then you have a urologist, and then you have Lipitor, or you've got, again, Viagra, right? That's a path analysis problem. So what is the path from the hospital I care about all the way to the guy who prescribes the most Viagra on a per patient basis? Right, this is kind of how you figure that out as you go. You do a search. So I think he runs a graph data set. What for your application, do you guys support what Gremlin and what's the big one? That's Sparkle?
Tinkerpop. Yeah, so we have a Graph API, so if you're going to get a little lower level access, we do have options that way. It isn't Gremlin, although we do support Sparkle.
Okay,
So we're already
apparently everybody supports Sparkle. There's a good open source graph database called Neo4j, which has its own little language called Cypher, which everybody seems to like. And you can use that to solve these problems. Gremlin is one, Sparkle is one, but Sparkle is really hard to use, but it's really robust and powerful. There are some new open source databases, like I think Titan is the graph database that runs on top of Cassandra, which is supposed to be really cool if you're a Cassandra person. And if you want to use Hadoop, you should look at Giraffe, which is how, so obviously, I mean, Hadoop out of the shell, when you see someone using a PageRank, how many people looked at the PageRank tutorials on Hadoop? You know, how to calculate PageRank using Hadoop on a set of, it's class things. PageRank is a graph-based algorithm. So anytime you have Pig can do, PageRank, and Hadoop can do PageRank, and PageRank is kind of the standard tutorial since it's a relatively simple. The simplest version of PageRank is a very simple algorithm. So anytime you see PageRank being demoed, you can use that big data stack to do graph analysis. However, Facebook released some code under the Giraffe project that allows it to do graph analysis on its data sets, which is Hadoop enabled but scales to the trillions of nodes. Obviously, for that kind of stuff, this is overkill. This is actually a relatively small graph. It's not that big, but it's getting bigger. So the two data sets that we have right now are the first one, the one that I kind of freed up is the provider to provider. And provider is a generic term. It's intended to refer to physicians and laboratories and hospitals, right? But there's a provider to provider edge database. That's the one that I filled out, that I got freed up. ProPublica did the provider to prescription or medication. And of course, there's all kinds of fun things you can do and put those together. Apparently, what is supposed to come out, if the American Medical Association does not sue to stop it from happening in 7 days, will be the provider to procedure database. So that's going to be pretty cool. If you go to blog, talking about important, blog.cms, this will, I don't know if you're actually going to save these videos or put them up online, but this will absolutely date this talk. Is the first article on blog.cms.gov is about this new data release that's going to happen within the next 7 days. So that's going to be the provider to procedure data set. So, the kind of things that I play with for doing this, when you're looking at a graph, one of the most useful and fruitful techniques are just going from a directed graph to an undirected graph, right? So let's say you have a primary care provider and you have a cardiologist here, and this guy's got a connection like this, and its weight is 1,000. Now, what this means in our data set is, in this particular data set, the directionality is weak, which is to say, this provider is clearly working with his cardiologist, and he's clearly sending a pretty fair bit of traffic to him. And even though we don't have the reverse, and we don't have the cardiology to primary care connection, that's only because the number of patients that are going back to the primary care provider, that does happen sometimes, does not happen inside the window enough for it to flag. Right? So anytime you see this kind of thing happening, there's probably a connection back. So if you're looking at the world from C's perspective, what you want to have is who's connected to me. Well, you don't want to exclude this guy just because it's directed in the wrong direction. So you want to flatten the graph, right? And you want to turn it from a directed graph to an undirected graph. So you want to move this over here, and so you just have a connection, and it's 1,000. Now, if you have a second group, right, this, and there's 1,000 and 100, you want to flatten this to one connection that's 1,100, like that. Right? Does that make sense? No arrows. You query this guy, you get this guy. You query this guy, you get this guy. Undirected graph. Does that make sense? So you can run a quick little pig script online, and you just take two copies of the graph, split it apart, put it back together. There's more efficient ways to do this with things like Giraffe. This is not the best, or somebody's got specialized hardware like Yark or somebody else. But for this size data set, pig is just fine. Having just an abstract layer, so you can run it through and do that. There's somebody who in the community, David, I think his name, who has released pig scripts to do PageRank with PageRank algorithm on this data set, which is invalid, right? That doesn't make any sense. So if you've got a cardiologist, and what it boils down to, how many edges you have coming in. A cardiologist who works with a lot of primary care providers a little bit is not necessarily any better than a cardiologist who just works with two. Right? There's no indication that these links are in any way connected to the quality of the provider.
Is that what you're trying to do? The goal here is to find differential quality trends, or
the goal here is to make a really good map.
But
for me.
But what does the map? What kind of trends are you trying to show with the map?
Once you have a map, you can search for operational efficiencies. You can search for cost problems. You can search for fraud problems. And people have done all of these things with the data set. You can search for what is normal, what is the most effective. So, for instance, let me just pull up on my little demo here. Another demo we can do. This is the demo of kind of major medications that we're prescribing. So what we've done is we've put together for a single doctor. Let's see if I can zoom that in once. All right. Okay, so in this display, all the colored dots, anything but light blue is a physician. All the colors are providers. This guy right here in pink is my doctor, Dr. Magid. I think that's him. Sometimes I change color. I think that's Dr. Magid. Yeah, it is. And what I did is I pulled in from the referral graph all of the physicians who are his specialists. And what I'm showing now is how that network of physicians interrelates and shares connections to medications, right? Very interesting stuff. So here you see the most expensive medications, since the size of the drugs on this one are on a basis of how much Medicare actually paid for them, are these heart medications on the side. These orange dots here, these three orange dots, they're all cardiology. I'll turn it to you in a second so you can see better. I won't give the explanation twice, but I'll turn it over there.
Sure.
So what you see here is that the cardiologist and the primary care provider are sharing a lot of medications. That makes sense. We've heard of these trends of cardiologists acting as primary care providers, and we've heard of these trends of cardiologists acting like primary care, and primary care taking on more and more management of heart-related conditions, because it's rampant. What we also see is that if you get away the random crazy drug for cancer is only given by his oncologist. The serious drugs on narcotics are given by his pain management specialist, which is all as it should be. But let's say, looking at this graph, and I'll turn this over so you can see it a little bit. Let's say we're just going to do an analysis of Dr. Magid. Dr. Magid lives in Houston. I can't remember what the name of this pain specialist is, but Dr. Magid does not have any relationship with the serious narcotics that are such that they can be detected with our stuff. So he's essentially prescribing near enough to zero that we're going to count it as zero for the sake of patient privacy, and which is good. We probably should count for zero in any case. Oxy and what else we got here? Common pain medications. Let me find this. Oxycontin, fentanyl, hydrocodone. These kind of names. Morphine. These are all done through the pain specialist, right? I'm going to call that pain. Call that primary care to be more specific. Right. So, is this graph better or worse or less or more effective than this primary care provider who's got a relationship directly with Oxy, directly with hydrocodone, and directly with morphine? Now, when would this happen? Well, this would happen when this doesn't exist. When there is no pain medication specialist. So for instance, if you're a primary care provider and you're in a rural area and you don't have access to a pain specialist, you are the pain specialist. Same thing as if you don't have access to a cardiologist, you are the cardiologist. Right? So one of the disadvantages and what I would like to get more of and kind of my, I don't know, the next 10 years game is to get outcomes data. Because while this is great, I'd like to be able to use the same network of data to evaluate whether this is better than that. And to have essentially, this is what the kind of, this is what's missing. If you guys think how to get this, I would love this. The problem is that outcome measurement is pretty hard. So if you're a hospital, you're typically measured on mortality you shouldn't have, right? So people dying from heart attacks in your hospital who shouldn't be, people dying from central line infections, you shouldn't be, things like that kind of tick against hospital quality. So we have a lot of quality measures and outcome measures for hospitals. But not dying is a fairly terrible outcome measure, because sometimes it's time for people to die, right? And you don't want to drag on, just because to get the right data point, you don't want to, extend someone's life unnecessarily, obviously. So dying is not necessarily a bad data point. Also, not dying is necessarily good. What is good? Having an episode and then having a good quality of life, sure, but nobody's tracking that. Nobody writes that stuff down, right? And if they do write it down, in the few times they write it down, they write it into their EHR systems. Their EHR systems will track that very differently. For someone who's like me, who's a data journalist, who wants to get at these issues, it's fairly difficult. But you can see how frustrating it is to have the top three and not the bottom one, obviously, because, so what? Is this better than that? Well, if you can find some way to, you can find outcome measures, and if you can find some way to tie this back in to an outcome measure, that's great. And people are looking at the data for that purpose all the time. If you want fraud to be your outcome measure, you can look for that. If you want, lowering cost to be your outcome measure, there's ways to look for that in the graph. So, the DocGraph project, our purpose is to have a really good map of the healthcare system. And we have a map that is unprecedented in the degree to which it's available. So if you wanted a map of the healthcare system and you had $100 million the year before I released my data set, maybe you'd be able to buy something and access it this way from IMS or somebody else who sells these kind of things for a lot of money. But as an open data set, it's been this huge revolution. All this is open data. Anybody can play with it. Anybody can use it and do analysis on it. Really interesting stuff. However, the golden outcome, or the key, whatever you want, whatever analogy you want to do. I'm mixing my metaphors, but any goal, the goal is going to be outcomes. And if you had good outcome data and you had good cost data, well, then you can really use this to reform the healthcare system.
Can you aggregate, the clinical endpoints of a treatment process in such a way that it's a proxy for outcome on average?
Yeah, and people are trying that. That's a really good idea. I, as a data journalist, I want to get just access to the right data.
Yeah.
As a data scientist, there's an awful lot of interesting things you can do. You can look at prescription of extreme pain medication as an indicator. So tramadol, for instance, has been this medication that's come out, and it's kind of a first stage intended use. It seems to be slightly less effective than the normal narcotics, slightly less awful for you in the long term. How much is that being used? Ambien is a Schedule 3 medication according to the DEA as far as it being addictive and everything else, and there's an antipsychotic called Seroquel, which has been prescribed in a rampant manner off-label. So it's labeled for use for antipsychotics, but physicians are more and more using it for sleep medication, and it appears to be slightly less awful for you than Ambien, right? So So there's a lot you can do. So you can look at, is someone prescribing the things you should prescribe? Like we know that certain things are not the right things to do for heart medications, for instance. These drugs have outdated sets of classes of drugs, things like this. There's all kinds of cases where the treatment is the outcome. And in all of those cases, or in the cases where you can create a reasonable proxy, there's a lot of interesting work that's being done.
What about situations like medical marijuana states where it's legal? Are there less per capita pain medications being prescribed in the states where it's not legal? Those kinds of questions are super interesting to see.
Oh, those questions are really interesting. And so, technically you would say medical marijuana is half legal, which is an interesting state. I have a friend of a friend is a DEA agent in charge of pharmacies, and she reminds me on a fairly regular basis that when you say marijuana legalization, what you're really talking about is no longer illegal in the state and merely a federal violation. So that's kind of an interesting progression. What that's actually going to create is probably a year from now, since there's any of these data sets you have a huge lag in, you're going to see something happening in the data sets going to Medicare. Who knows what? Medicare, I think Medicaid data would actually be more interesting. It's really hard to get Medicaid data since the reporting from the states who administer Medicaid is not nearly as good as the centrally administered Medicare. So there is a big database in the federal government for Medicare. There's really not for Medicaid. There's state level databases, but there's not. And so just to remind everybody who's not a super healthcare wonk, Medicare is old people, Medicaid is poor people. So if you're looking at pain treatment, Medicaid might be more appropriate to see some of these kind of shifts, but there's also a year lag no matter what you're doing. So sometime soon, we will have the data we need to do some formal analysis of how medical marijuana is going in terms of a kind of black hole analysis, what's missing, seeing the gravity for something that's not there or not actually in the data set. So that's going to be really interesting. Any other questions?
Just a quick one. I know that there are some policies now that seem to be shifting toward more value-based medicine, and it does seem like there are at least some systems in place to collect feedback from patients. Is that data going to be released publicly? Or
some of it already is. So, for instance, if you look at this has been a problem for a year. Before my data set came out, which was the first of the 3 of these to come out, there was really nothing about providers. Like, there's all kinds of hospital quality data, and one of the things that is if you want to look at that, is the Hospital Compare data set. There's a website that's run called Hospital Compare by CMS, and the data behind it, the scores behind it, are released to the public. There are all kinds of interesting information like central line infection rates, things like this. And one of them they have is the I want to say PCORI, but I know that's wrong. That's the new program to do patient-centered research. All of that's actually going to be another source of relatively interesting patient-related data. I can't remember. There's a survey that is in the patient survey data that comes out in Hospital Compare.
Yeah, and I was wondering if that would be some indication of the outcome. If you could just ask the patient how your experience was. I know that's not a direct link necessarily, but if they've had a positive experience and they were willing to agree on a survey
that certainly matters. What's really interesting is that people did an analysis from the kind of formal patient surveys and found that Yelp, there was a study that showed that Yelp reviews were actually on par with those. So we don't have evidence, really strong evidence that, we know there is some evidence relating to how patient surveys tie back, because when you do a formal patient survey, you're trying to ask them things like, how clean was the room? And, were people on time? And kind of objective questions as opposed to, did the doctor do what you wanted? Which, of course, would be a terrible indicator, right? So that you're trying to kind of use a patient survey in a way to get cleaner data out of patients. It's interesting then that ties back so heavily to Yelp score. So it seems like what might be happening as a result is, if you're the kind of patient who might be willing to go flame a doctor on Yelp, you're also saying that he had a dirty room. So that's not great. So I'm really dubious about patient-generated health data because, unfortunately, it's subject to a pretty substantial bad actor problem. It's kind of like spam on the email network, and I don't know how to address that. I do think it matters, though, and I'm very interested in seeing how patient-generated data can be used to kind of get more positive feedback, but I'm looking for more objective data from patients rather than just do you like your doctor. The most famous problem, of course, is the antibiotics, which is a problem that's fairly well out of control. Is there's a pretty strong correlation to whether or not you gave your patient antibiotics that they didn't actually need, to how satisfied they are with you. And if you refused a physician refused a patient antibiotics and they ding them on their patient evaluation scores, that costs the doctor money now. And so there's a lot of doctors who you come in with the flu and it's clearly either can't tell whether or not that's viral or it's not clear whether the condition deserves antibiotics. There's a lot of physicians who just write the antibiotic script because they know they're going to get dinged on something that ultimately hits their pocketbook. That's a real problem from a public health standpoint, and I think you should be able to start seeing things like that in the data. You should be able to start seeing who is prescribing in a way that is kind of catering to inappropriate patient requests.
One thing is you can see the same thing in certain scheduled drugs also.
Well, I mean, there's lots of people who've started to look at this from a pain medication and narcotic perspective. One of the interesting things that I'd like to be able to do, and I think we'll be able to put ourselves in a position to do soon, is there's data in the state medical boards about how many physicians have been censured for giving inappropriate levels of narcotics. Now that sounds like a bad thing, and of course there's a lot of concern and drama about pill mills, but what we see, and this is anecdotal, I have not done this data, but I'm going to start looking for this. You can actually take a physician to a medical board to be censured the same way, for any problem, for failure to control pain. So obviously narcotics are inappropriate or deemed inappropriate for low to moderate pain, but for moderate to severe pain, very often narcotics are the only option. And even with their habit forming, you just kind of make a decision, this person has so much pain, we're going to make them addicted to this this narcotic. It's just the way it's going to be. It's not a big deal. It's just we have to do this, and there are all kinds of consequences for that. But in many cases, narcotics are the only thing you can use. So, in a state like Texas, my understanding, talking to people who are knowledgeable, is that you don't see any attempts to censure physicians based on failure to control pain. Instead, you see them only censured for doing the opposite error, right? Because it's clearly a type 1, type 2 problem, where they've been censured for doing too much. In other states, that's not true. You can see the other thing. You can actually see people who are being taken to task for not controlling pain. Unless you have a mechanism to actually measure both the failure to control pain and the narcotics, I'm kind of against doing those data analysis, since what you're doing, if someone looked at my database without the, again, outcome measure of how much is pain controlled, and they just did an analysis of narcotics, well, on its face, that analysis is invalid, since you're measuring only one of the two variables that matters for this. And that outcome variable is so really important. So, anyways, those are the kinds of, things I think about trying to do.
So a little bit off track. Those open data sources, not every which is available, but let's say the ones which are used by government, so kind of like more official, like more correct data, let's say. How big they are? The question is motivated, if I would like to do something like what you are doing and try to analyze those things, come up with interesting scenarios, which infrastructure I would need to start playing with them? Are those gigabytes, terabytes, petabytes?
Well, thankfully, this is really just barely pouring into the big data range. So what we have been doing most of our analysis with, we bought a computer that had 64 gigabytes of RAM, one server, and now we're getting one that has 128 gigabytes.
So all this data you are analyzing
we can easily. That's the problem, is that now a single server is starting to show. It's starting to cramp a little bit as we get more and more of these. So
for fast processing, are there available any memory graph engines that you can store and process?
So Neo4j, if you've got it running, so the problems with Neo4j, Neo4j is a graph database. It's a very good one. The problems with Neo4j start pretty soon after you get a little bit bigger than this. So Neo4j is kind of ideal because its weaknesses, to the degree there are weaknesses, and they're kind of working on them. In fact, they've done a lot of significant improvements on this, is in sharding. So it's fairly hard to shard a graph data set, right? And Neo4j has had some weaknesses in that area, although again it's improving. So Neo4j is kind of ideal for us. You put it on a single really big server and then you use Neo4j. That works pretty well. There are people who have used Craze. I believe there's somebody who's used Yark. I believe there's people using Titan. I believe there's people using Giraffe.
Just a quick question in the same direction. What about Palantir technologies?
Palantir?
That's, because they have this concept of really like inflatable cluster, right? So you can really like tune up the whole thing. And it's graph analytical too, right? So
No, I mean, I haven't heard of anybody using Palantir, but their technology is kind of ideal for this. It is graph-oriented and is, cluster-oriented. So yeah, that would actually be a good way to look at it. Palantir is pretty expensive. I tend to focus on things I don't have to pay for.
And visualization from the best visualization of big graphs.
So if you're going to do visualization of this stuff, we have gotten a lot of mileage out of D3's force directed. So anytime you're looking at a slice, and that's actually the other convenient thing for analyzing this is, it's pretty easy to slice this data. So you could take every physician in a metropolitan area like New York, and then you've made a much smaller graph for yourself. And the interactions between New York and an LA from a healthcare perspective are minimal. You do see it. And in fact, there's somebody who did a really cool analysis of between state referrals, but it's a trivial subset of the data. It's very, very small. So you can make it smaller and make it easier on yourself. And one of the things that people have had a lot of success with in visualization is using Gephi to look at a small city or a large city or a small state. And that's the point at which Gephi starts to break down. Of course, Gephi has all kinds of fun algorithms that you can run on graphs.
So I've used both Gephi and D3, and Gephi I don't find works well with large data sets, big data level data sets. D3 is gorgeous. It works really well. So Gephi we do use to do calibrations on pilot data, but if we want to display lots of data, we always use D3. It works great with Elasticsearch and HBase, and you can get all kinds of libraries for free, open source, that are fabulous. So.
That's really interesting. I would have guessed the opposite. Although we've seen D3. In fact, I've got one of my demos here. I have the D3 pulled up of New Orleans. You can see all of it, and it's pretty crazy that works.
We're in the trillions of edges kind of data space. So we're stress testing Gephi, and it's impossible to use Gephi at that scale.
No, the Gephi stops working pretty soon after a city for us.
Yeah. I have three related questions, one of which I think you'll really enjoy, and two you'll find boring but are probably useful for us. The first one that's probably boring to you is, what data sets what are you FOIA-ing, like Medicare and Medicaid records, or what other kinds of data sources are you going after?
So for us, data sources that are interesting are, there's a lot of stuff left in claims that we would like. Mm-hmm. I would like to know, for instance, I don't know what's going to come out in this procedure data set. I have no idea. And someone tell me when my session is over, by the way, just for
about 5 minutes.
Great. So what I would love to know with procedures, and they have not given me this, and I'd like to know about prescribing, is more about how they're just prescribed together. From my perspective, if you're prescribing a medication and you're also prescribing the medication that deals with the primary side effect of that medication, that's interesting, right? But the data that we have right now is single point, single edge. I don't have pairings and groupings to know that one patient got these two procedures together, or one patient got these two prescribings together, or even to know that a particular diagnosis was mapped to a CPT code. Again, I don't know what's going to come out, but I expect to be disappointed because they're doing this release in response to a FOIA request that I did. Yeah. We had U.S. News replicate our FOIA requests. So what is a common strategy to turn something from a FOIA request into a public data set is, once a FOIA request has been replicated a number of times, they're required by law to just put it up. It's kind of the e-FOIA amendment to FOIA is this rule. So we had US News replicate our FOIA request, and so when you have lots of FOIA requests being repeated, it's a way to create these data sets. So what they're probably going to be putting out is kind of something intended to satisfy not only our FOIA requests, but the hundreds of FOIA requests that went in at that time when the court case was overturned. So I asked for all kinds of pairings and all kinds of complex stuff that will let you do cluster analysis on procedures and diagnosis, all kinds of interesting stuff that I know I'm not going to get. But so that kind of cluster analysis approach, I'm really interested. So claims are not done, right? But I'm also interested in more about pathways. So, for instance, I'm interested in understanding more about how patients bounce around in the healthcare system, not just point to point, but like 1, 2, 3 maybe.
Yeah.
I'm interested in obviously the first thing I'm interested in is just in general stuff to do with physicians. So I'm interested in the way physicians are effective. Do they move between? There's a database called the National Provider Data Bank, which is the place where all serious complaints against physicians are stored, and that's private. The government does not allow private citizens to view that. It does allow hospitals to view that, so that if a really bad doctor is moving to another hospital, there's a way for the previous hospital to let all the other hospitals know that there's this terrible doctor. And actually, there was a case in Dallas of a spinal surgeon that was fairly egregious recently, that was representative of how this system is kind of a little too slow. So it looks like you killed or paralyzed some people, in that window of time that he wasn't in the database and things like this. So I'm also interested in other things about the healthcare system. So I'm interested to know about the efficacy of medications, just looking at the whole world as a graph of medications. I'm interested in doing efficacy of foods. So foods right now are not treated like medication databases, but they probably should be.
How would you get access to that data?
So most of it's on the back of your, Starbucks thing, right?
But you don't know who's eating what.
Who's eating what is something, that's the thing, is that getting patient data at scale, that's another problem, and I haven't tried that. And if you're interested in that, I encourage you to Google John Wilbank's TED Talk about people donating their patient data. It's a great idea, but we haven't tried it yet. So I'm much more interested in just knowing what is in different foods and things like that, so that's something else I'm interested in. So that's just the first question of 3 you had, so go ahead.
The second one is related to part of your answer for first, which is, are you using machine learning algorithms to look for unexpected trends like maybe graphlets or something like that at scale?
I wish I was. I mean, the problem is that the word unexpected here has no meaning. I don't expect to see anything. So,
okay. Fair enough.
So the notion that I would be able to describe in any kind of inaccurate way what unexpected would mean is somewhat hopeful. The simple reality is that before these data sets came out, we have had no idea how the healthcare system functions. We don't know what's normal. We don't know what's typical. I focus on that question a lot. Can I tell the difference, and in a kind of a regular way? Can I say, this is what a normal primary care provider does, and what this guy is doing is different from, I shouldn't say normal, average. This is what the average does, and this guy is not average. That actually would be pretty useful. Sure. And I'm teaching myself the graph science. I need to be able to do that.
Yazdi, by the way, you probably know those guys in Palo Alto.
Who is that?
They do Yazdi, A-Y-A-S-D-I. They do topological data analysis.
Was it Y?
A-Y?
A1.
A-Y-A-S-D-I, something like that. Yazdi. That's
I think.
Yeah. And so they...
Yazdi.
Yeah. So they
do stuff like that?
They do outlier analysis on graphs. So they look for, any kind of...
I should call them.
Extreme trend. Totally, they would love to. I'm sure that'd be
Beautiful
fruitful.
visualizations too.
Beautiful visual. Yeah, just check out their website. You'll know immediately how.
I will. That's great. Thank you for the tip.
The machine learning algorithms?
Just so you know, we have a community of data scientists.
Yeah.
So in many cases, we're not doing enough at all. But you know, we would love for you to get. There's a DocGraph mailing list. We'd love for you all to join. And you know, if a vendor wanted to take the data set, do a demo, show something interesting that they've done using a technique that only they can do, or something else like this, that kind of quasi-advertising stuff is more than welcome on the mailing list.
Very cool. Okay, last question. Hopefully it's fun for you.
We'll see.
What would be the one data source that you would love to have access to that you don't? Like, what is that holy grail?
Well, practically, what I can make the most money off of right now would be what the insurance companies have. And I say that because the only thing keeping me from that is their greedy little mitts. There's no reason at all why you couldn't replicate all the stuff I'm talking about on Blue Cross Blue Shield, Aetna, Cigna. There's no reason why they couldn't release the same data. They just don't think about the world that way. Obviously, I think patient data is kind of the long-term holy grail, because most people just throw away the data about themselves on a regular basis. I mean, there's tons of people here using Fitbit, no aggregation, no public stage. So there's all of these companies. Actually, that's it. It's all the stuff behind the curtain, right? So Fitbit has this amazing stuff. You guys remember the Zeo? The Zeo. So the Zeo was this funny thing that had to sit on your head like this you went to sleep with. And it compiled the largest single database by, I think, 2 orders of magnitude that had ever been compiled before about sleep patterns. And they went out of business. They went under as personal tracking devices are want to do. They couldn't find a business model, and it just went away, right? And I think they sold their database at auction, and nobody has any idea who actually bought it. So that's just tragic, right? So we're gathering these patient data sources. Let's say a doctor is 67 years old, 65 years old, decides to retire his practice. People just throw away their paper patient records. So that might be your grandmother or your mother's record that are in this kind of random doctor's trove, because generally when a physician sells their practice, the patient records historically have been one of the things that you pass along. So, and then you get a doctor that's had, could have patient records from the 1800s being passed along that way, paper, and then they just get thrown away or put into storage and then thrown away. So that's really tragic. And I really wish I could figure out a way to do something with that. And I have some ideas, but they're pretty fanciful at this point. Somebody like Google might be able to execute them, but not me.
Oh, thank you. And it's past your time, Jesse.
All right, thank you. Does anybody else have any questions?